So here Frodo graphs the polynomial function f of x. And here's its graph in blue. So we'll come up here with blue and say this is f of x. And it's got a multiplicity happening at -2. Remember, a multiplicity just means the same factors occurring more than once, which means you're having repeated factors, you're having repeated zeros, but you can only plot a zero once on the graph. So in this case, it's a multiplicity of 2. And if we go back to lesson 10, I believe it was, if you have a multiplicity of 1, so if you have multiplicity of 1, then you kind of cross, right? You cross that graph. If you have a multiplicity of 2, then it kind of bounces or it touches and moves back, changes direction. Remember, a multiplicity of 2 kind of acts like a quadratic at that 0. So it kind of bounces or it turns. So it could look like this, or it could kind of act like a quadratic there. And then if you have a multiplicity of 3, you want to think about a cubic. It kind of curves, crosses, and then kind of curves again. It kind of looks a little bit like a cubic function looks. So number 1, if we go back to f of x, number 1 is asking you to determine if Frodo's conclusion is true or not. Frodo says that f of x has 2 zeros and therefore must have a degree of 2. Based off of the conclusion in problem number 1, this is a sound reasoning. But now we've got multiplicity going on, and that kind of changes how we look at the degree and the number of zeros. So I'm going to go ahead and agree with his first part. I'm going to agree there are 2 zeros, because he is right. We have a 0 at -2, and we also have a 0 at +1. But I'm going to disagree and claim this is a degree equal to 3 because, can't spell because we have a repeated factor, or we have a multiplicity of 2 at -2. So I'm just going to highlight this polynomial for you guys real quick, and I'm going to expand it out just to prove to you that it is a degree 3. So if we come in here and we rewrite f of x and we expand it completely out in factored form, you're going to have x plus 2 times another x plus 2, because you're squaring it, times an x minus 1. And that is why I'm claiming that this is actually a degree 3. Because when you put this all out and you multiply all of the first terms in each of the factors, you're going to get x times x times x, and that is an x to the 3rd power. So even though this polynomial has only 2 zeros, because of the multiplicity happening in the repeated factor, it really is a degree 3. Problem number 2 wants us to look at another polynomial, and it gives us the zeros and whether or not they have a multiplicity. And we have to predict the degree of g of x. So I'm just going to sketch it first, and then I will go ahead and we'll make a prediction on the degree. So we've got x -4, -1, -2, -3, -4 is right there. And then we got another 0 at 2. And then we got another 0 at 7. 2, 3, 4, 5, 6, 7. So this x to the -4, this is with a multiplicity of 3. So it acts like remember its factored form is going to be x plus 4, but it's a multiplicity of 3, so you have that factor 3 times. So this is going to act kind of like that cubic function. X to the 2 right here, right? So it's x minus 2. That is a degree 1 because there's no multiplicity, so there's only one factor for it. And this is going to be x minus 7 with a multiplicity of 2, so it's going to act kind of like a quadratic. So let's get in there. Oops, sorry. And try and sketch it. So I'm going to act like a cubic first. So I'm going to come up, start to curve through it, cross it, curve again. I'm going to come back down. I'm going to cross through this one because it's a multiplicity of 1. I'm going to turn. Multiplicity of 2 means I'm going to act like a quadratic, touch it, bounce back down. And there is a possibility for this polynomial g of x. I feel like that wasn't the best cubic curve right there, but you get the idea. So we're going to put a multiplicity of 3 and then a multiplicity of 2. So because it's a multiplicity of 3, that basically means we've got, I'll write the function out for you guys. So g of x, you've got this guy 3 times. X equals 2. You've got this factor, x minus 2 once, and then you've got this factor, x plus 7 twice. If I were to condense that, you would write it as x plus 4 to the third power, x minus 2, and then x plus 7 to the second power. So the top one's its expanded form, and the bottom one is its condensed form. And 1, 2, 3, 4, 5, 6. So there's my degree. This is a polynomial equal to a degree 6. How do you think you would get that answer without actually having to write it out in that top expanded form? Is to add up your exponents. You've got a 3, a 2, you got an not imaginary, but kind of like an invisible 1 there, right? 3 plus 1 plus 2 is equal to 6.